surface area of a lateral surface.
Lesson 15 is very important. This is where probably the first lesson of this book where I see students maybe not get a good grasp of it and then struggle for the rest of the year with surface area. I'm going to guess as to why. Okay, we're talking about three-dimensional objects. So here I have one. I have what we call a right geometric solid. The reason it's right is because if I lay it down, it's straight upright. It's not bent or slanted. Okay, when I stand that up, it's straight up and down. So meaning there's right angles in there. Okay. This one is actually called a right rectangular prism. Okay, meaning it's got a rectangle and, well, it's got a square there too, which is also a rectangle, but it's made up a bunch of rectangles, okay? And I think people get surface area confused with volume because we have a three-dimensional object, but when we're looking for surface area, we're talking about flat, two-dimensional areas added up. Okay, what we're saying is for surface area is we want the area of each side of these, and there are 6. There's a top and bottom, two sides, we could say, and a front and a back. So there is 6 sides to this one. Now later on we're going to do some figures that are not 6-sided. Okay. In this case, what we're going to do is take all of the areas of the sides and add them up. Okay, so you're going to find 6 measurements and add them up. But as you notice, 2 of those, the area of this rectangle and the area of the back rectangle are going to be the same. The area of the top is going to be the same as the area on the bottom, and so on, okay? And the book kind of shows you a little bit of that. Now my first picture here, I'm going to get something kind of similar to it. So this is actually a square box, but this one is a 2 by 4 by 3. So let's just pretend this has the dimensions of the picture. And I've got a top and a bottom, a front, probably a back over here, and then the sides there, okay? And they want us to find the surface area of this right rectangular prism. And the dimensions are in centimeters. Okay, so what I'm going to do is show you a trick here. My box, my right rectangular prism, has something inside. It has all the sides, and then we can undo it. Do you see that? We have 1, 2, 3, 4, 5, 6 sides to our figure. So one way to think of this is by taking your figure, unwrapping it, and adding up, and now finding the area of this. They call this a net. So we're really looking for the area of this shape here. Okay, so let me put that aside. I just wanted to give you a visual, and we're going to work through this problem. Okay, I labeled top, front, and side so that we can figure out all the different areas. Okay, so let's get the area of the top. What I like to do is write A for area, and I put a little sub T, A sub T, which means area of the top. And remember, area of any rectangular shape or any rectangle is length times width, right? So if we plug in what we know, our length of the top, let's see here, if we look from here to here, okay, we have a 3, and then from here to here is a 4, okay, so it's 3 by 4, so it is 12 centimeters squared. Let's see if we can make sure that I'm in focus. Let's do the same for the bottom. The bottom, if that's the top, the bottom is exactly the same. I'm just going to go ahead and write 12 centimeters squared. Okay, it's the bottom has the same 3, by 4 dimensions. Okay, so now let's do area of the front. And it looks like we have a 4 by 2. So length times width, and we get 8 centimeters squared. Okay, so we've got 3 of the 6 sides. If we did the front, let's do area of the back. Now I have 2 B's, but for this purpose, I think we're fine. So if the front is the back is going to be identical to the front, so it also is 8 centimeters squared. Okay, and now we've got the sides. Okay, so the side is 3 by what? What is this? It's a 2. Okay, so area of the side is 3 by 2 is 6 centimeters squared. And then the same as the other side, because they are identical. Okay, so we found all 6 of the sides for our surface area. Our total surface area of this whole prism is all of these areas added up. I think a lot of people don't realize that surface area actually probably takes the most time when we are dealing with geometric shapes, okay, or solids. So if we add those up, we have 12, 12, 8, 8, 6, 6. Now I like to find shortcuts. 8 and 12 is 20. So we have 20 and 20 plus 12. So we get 20 and 20 is 40 plus 12. We get the surface area is 52 centimeters squared. Okay, so you're going to get a chance to do that in your practice. All right, now we've got triangular prism. Okay, so I'm going to pull a triangle out. It's not exactly the same shape as this, but here it is, and I'm actually going to take the net out so we can look at one. Okay, here is a net of a triangle. Now isn't that weird? In fact, we have 3 squares or 3 rectangles and 2 triangles to add up. So that's interesting. Let's look at our picture and see where we can find those, okay? All right, well, see a triangle is here. We're going to call that the front, okay? The front and back are triangles, right? And then we could call this the top, but we don't have a bottom, do we? And then maybe under here would be a side, and under here that you can't see would be a side. Okay, so if we were to draw in the part we can't see, you see now we can see the pieces. Okay, so 2 triangles, 2 rectangles, and then the top rectangle. So we actually only have 5 sides, right? Instead of, so we have 1, 2, 3, 4, 5 sides instead of up here where we had 6. So let's go ahead and find all these areas. Now again, the rectangle areas probably be the easiest. So let's go ahead and do those. The area of the top would be this one. It's a 5 by 6, right? 5 by 6 is, I'm going to go ahead and write it. 5 by 6 is 30 meters squared. Now remember, we're doing squared, not cubes, because we're not doing volume. Okay, we're doing all of the flat sides around. Okay, we can flatten it out, so that's why we're doing area. Can flatten it out. Okay, so area of the top, area of one side is, we have 3 by 6. And yes, these take a lot of writing, don't they? And that's okay. You need to write a lot. If I see you turn something in that is, especially on a test and it's surface area and you barely have any work, I already know it's going to be wrong because you probably made a mistake somewhere. Because it takes a lot of writing. Okay, so this side here, if I shade it in, what are the dimensions of that? It is a 4, and then how far is it from here to here? Okay, it's 6. Okay, so it's a 4. I'm just going to write another S. It is a 4 by 6, so it is 24 meters squared. All right, now we've got our triangles. Now both triangles are the same, so that's helpful. Area of, I'm just going to write a triangle. Area of the triangle, or we could say front, is, do you guys remember? 1/2 base times height. area of a triangle is 1/2 base times height. Okay, so let's go ahead and put in the dimensions of this triangle. We have a 3 by 4. And then we calculate that. It's 12, and 1/2 of 12 is 6. Now we have 2 of them, so I'm going to write that out again, and we have 6. Okay, so do we have our 5 sides? 1, 2, 3, 4, 5. Yes, we do. We add all those up, and what you should do I'm just going to give it to us since this is an example, but I would just go ahead and use this side over here to add up my numbers to make sure I didn't make a mistake. I hate to see you get all this correct and then do the addition wrong. Okay, so when we add that up, I'm going to cheat so we can move to the next example. The total surface area is 84 meters squared. Okay, now we're going to go to another shape. Okay, this is probably the hardest one. I would say this is what messes people up. How many sides does this have? That's pretty confusing, isn't it? Well, 1, 2, and then a big curve all the way around. This is like a soup can with the label on it, right? If you pulled the label off of a soup can, if you pulled the wrapped around label off a soup can, what shape would you get? Okay, we already know we have a top and bottom, and those are circles. I will show you. Here, this is a cylinder. Okay, let's unwrap the soup can. Let's see if you can see that. Okay, do you see that? I have 2 circles and a rectangle. And that's interesting. So somehow we can get dimensions of a rectangle by looking at this. That's the hardest part. Okay, we get the area of circle, area of this circle, and then to find this, what we do is figure out, okay, it was around like that, right? Okay, so it was the length of our rectangle here is actually the circumference of this circle. How far around that circle is how long our rectangle is. Our width of our rectangle, there's a picture of this in the book too, the width here was 10. Okay, so we know this is 10, but the whole rectangle is going to be the circumference of the circle. Okay, look in the book and just try and understand that. Where do we get the length of this? Okay, the long side of our soup label. Well, it is the circumference. Okay, so if we want to find the area of this rectangle, I'll go ahead and draw this. I want you to notice it. The area of this soup label is, this is a really small drawing of it, not to scale. It's a 10, and then this is the circumference of this circle. So circumference equals 2 pi r. Now that might be a long time ago that you've used this, but 2 pi r is our circumference, or pi d. Okay. So to find the area of this rectangle of the soup label, we would multiply the circumference times 10. So let's go ahead and do it. This is called the lateral surface area. Okay. Lateral surface area is the area of the curved surface between the bases. Okay. So I have a formula for lateral surface area. The lateral surface area equals, the lateral surface area is the perimeter of the base times the height.
The lateral surface area of 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 a solid is equal to the perimeter of the base times the height times the height times the height times the height times the height. The lateral surface area of a solid is equal to the perimeter of the base times the height times the height times the height times the height times the height. The lateral surface area of the lateral surface area of the lateral surface area of
Okay, so and the perimeter of the base turns out to be our circumference. Okay, so our lateral surface area is 2 pi r times h. Okay, so that's how we get this soup label, the label part of our area. Okay, so let's plug in what we know. 2 And I'm going to leave this in pi. Our radius is 4, and our height is 10. Okay? And let's go ahead and calculate what we have there. That means we have 2 times 4 times 10, which is 80 pi. And I'm going to leave it in terms of pi. Okay? This is in terms of pi. If we were to multiply that out by 3.14, we would get, you can write this, 251.2 inches squared. Now, I want to see answers in terms of pi. It's easier for you, and it's easier for me. This means I took a step further and multiplied in a calculator by 3.14. I don't want to have you wasting time doing all that calculating now that we're in algebra, okay? We're assuming you've mastered that. All right, so now we have the area, the lateral surface area equals perimeter of base times height. Now what we're going to do is add the 2 circles, the area of the 2 circles, to get our total surface area. Okay, so do you see how there's going to be a lot of writing for this one? So the area of the circle is pi r squared. Okay, so let's plug in what we know. Okay, and so then we get 16 pi. And we're inches squared. Okay, now that was one circle. Area of the other circle is also 16 pi. So our total area, our total surface area, I call it SA, of the whole cylinder, is going to be 80 pi plus 16 pi plus 16 pi. Okay? 80 pi plus 16 pi plus 16 pi. Now 16 and 16 make 32, plus 80 would be, what did I just say? 32 plus 80 is going to be 112, okay? Now we're going to have inches squared. Oh no, pi, sorry, 112. So 112 pi. Make sure this pi is on here because really this is times 3.14, but we're not going to go ahead and multiply that through for your answers. We're going to leave answers in terms of pi. Okay, I'll talk to you about that in class. And there's our final answer. Now, if you look in the book, their final answer was 351.68. Okay, so let me just show you something. What if we took 112 times 3.14? What do we get? 351.68. So we would have the right answer, but I'm not multiplying by pi. I'm leaving it in terms of pi. Okay, example 4. Now we've got this shape. Okay, this is an interesting shape. And what I'm going to talk to you about is that we have another formula. Okay, well, let's just read this. A base of the right solid 10 feet high is shown. Okay, the 10 feet high. So I'm going to write this right here. This is 10 feet tall. Okay, find the surface area of the right solid. Dimensions are in feet. Okay, so here we are. We have, this is the top and the bottom. So we have what the top and bottom look like. Okay. But the lateral surface area probably be the hardest thing to find. Okay. Instead, we're going to call it perimeter of the base times the height for the lateral surface area. Okay. So let's find the lateral surface area is the perimeter of the base. Okay, so here's the perimeter of the base. It's 5 plus 6 plus 5 plus half of this circle. Oh boy, this is going to be hard, right? Lateral surface area equals perimeter of base times height. All right, so that means we have to find the perimeter of our base. Okay, well, let's figure out the distance from here to here. Okay, now that is a circumference of a circle cut in half, isn't it? So let's find the circumference of this circle. So I'm going to go ahead and say C equals pi, oops. I'm going to go ahead and say C equals 2 pi r. Okay, and we're going to cut it in half because it's half a circle. So we put it over 2. This is all new, so we're going to have to practice this a lot. So now I'm going to plug in what I know. The r is 3, the radius is 3, and it's over 2. Okay, let's leave this in terms of pi. 2 times 3 is 6 pi over 2. 6 divided by 2 is 3 pi. Okay, so we just found some of the perimeter of the base. The rest of the perimeter of the base is add 5, 5, and 6. So perimeter of the base equals 3 pi plus 5 plus 5 plus 6. Okay? And we cannot add these to pi. So what we do is leave it in terms of pi this way. 3 pi plus 16, and we're in feet. Feet, okay? So that's the perimeter of the base is 3 pi plus 16 feet. So now let's find the lateral surface area again. Lateral surface area equals perimeter of base times height. Do we have the perimeter of the base? Yes, we do. It is 3 pi plus 16, and now we're going to multiply that by height, 10. Okay, now this is hard for those of you, because we're leaving it in pi, I'm not sure if we remember the distributive property. But what we need to do is multiply 10 by both of these guys in here, and I will work with you in class. Okay, so what we get is 10 times 3 pi, which is 30 pi, and 16 times 10, which is 160. And we've got, there's our lateral surface area, 30 pi plus 160 feet squared. Now all we did was get the label. We don't have the area of the top and bottom yet. So do you see why these are a little painful? Okay, so all we have is the lateral surface area, but we don't have the area of the top and bottom yet. So let's figure out the area of the top and bottom. The area of the top is this rectangle plus the area, half of a circle. Okay, so the area of the circle now, or of the semicircle, is pi r squared, and our radius is 3 squared. Okay, so, and then we're dividing it by 2, aren't we? So I'm going to go ahead and put that divided by 2. So what we get is 9 pi over 2, and we're going to leave it like that. Okay, so there's the area of the half circle, and then the area of the rectangle is 5 by 6, length times width, so we get 30. And so the area of this whole shape here is this and this together. Okay, so what we say there is the area of the top equals 9 pi over 2 plus 30. Okay, now what about the area of the bottom? Same thing, 9 pi over 2 plus 30. So our total surface area now is this plus this, isn't it? Okay, so you might be thinking, this is awful, Mrs. DeShiel. It kind of can be, but maybe I'll let you use calculators and multiply by pi. I'll think about that. It might be easier. We'll work on that maybe on your practice. Okay, so let's add those up. I'm going to add up all my pi's first. Okay, now I have 2 of these. I don't know if you realize this. 9 pi over 2 plus 9 pi over 2 is going to be 18 pi over 2, which is 9 pi. Okay, so 9 pi plus 30 pi is 39 pi. You might need to rewind this and listen to it over again if you don't know where I get these numbers. 160 plus 30 plus 30. Okay, 60 plus 160 is 220. And I'm going to call that feet squared. Okay, do you see? Here we go, looking at this surface area. Like I said, I think these are the easiest because we really only need to find 3 areas, okay? The front, the top and bottom, and the sides. Okay, so let's find the area of the front. The area of the front is 2 by 4. So equals 8. Dimensions are in inches. Okay, that means the area of the back is also 8. Okay, area of the top is, looks like a 3 by 4. We got 12 inches squared. And that means the bottom, 2, is 12 inches squared. Okay, now we've got the sides. It looks like we have 3 by 2s. I don't know why I wrote a T there. It should be an A. Okay, area of the side is 3 by 2 equals 6 inches squared, and so there's the other side. I don't know why I wrote another S. Area of the side, I think because I'm trying to go fast for you. Okay, so hopefully when you did these, this one you did correctly, okay, because this is the most basic. So we have 8, 8, 12, 12, 6, and 6. So those are 20s, those 40, 52. Okay, again, it looks like we had the same as the first example. 52 inches squared, okay. I'm going to write surface area equals. Okay, let's see if this is going to get any harder. Yes. Okay, triangles. Find the surface area of this triangular prism. Dimensions are in feet. Okay, so we've got 5 sides again. We've got 2 triangles, a side, and a top. Let's go ahead and find the area of the 2 triangles, okay? And they're going to be the same. So I'm just going to write A equals triangle, and we're going to say it's 1/2 base times height equals 1/2. The base is 8, the height is 6, and what that is half of 48, which is 24. Now there's 2 of them, so I'm just going to write times 2 equals 48. Okay, kind of snuck it up there. Hope that's okay with you. And we're doing feet, so 48 feet squared are our 2 triangles. Now if we do that, if we double it here, don't forget and double it again. I've seen that mistake done quite often, so let's be careful. Now let's do the area of the bottom, and that's a rectangle, so it's going to be an 8 by 12, it looks like, and that is 96 feet squared. Let's do the area of the side, and that would be, if we drew the dotted lines to really see, it's a 6 by, this here is 12. Okay, so it's a 6 by 12, and that is 72. Now I hope you know your 12s because they'll get used a lot. Area of the top is 12 by 10. Okay, 120 feet squared. Now our total area is this, because remember this is worth 2, this is 2 sides, 3, 4, 5. Like we said, we had 5 sides. So let's add up the first 3 and then add 120. 48, 96, and 72. And add those up. And then let's add the 120. So we add those. We get 336 feet squared, and put a nice box around it because it's good after all this work to give it a nice box. Okay, now before we go to letter C, I just want you to know this is an edit. I actually I made a mistake. And so when you see on the next clip, you're going to see this number wrong. I think I got in the 200. So I made a mistake and had to go back and fix it. So when you go on to letter C, which is going to happen in a moment, you're going to see the wrong thing up here. Just ignore it. 336, that was the correct answer. Second to last one, we've got a cylinder, so we have a lateral surface area 1. Okay, so let's go ahead and get the area of the circles. Okay, and there's going to be 2 of them. So area, it looks like we've got 20. So we've got pi times 20 squared. And then I'm gonna put an S there. So it's area of both circles. So do you see why I doubled it? Because I have two circles. So now I'm gonna calculate this and leave it in terms of pi. So 20 times 20 is 400 times 2. Okay, do you get that? 400 times 2 is 800 pi. There's the area of the circles, centimeters squared. Now we're going to get the lateral surface area. Okay, remember the lateral surface area is the perimeter of the base times the height. Now the base, because it's laying down, we want to think of it standing up, okay? The perimeter of the base is 2 pi r, because it's a circle, and h times h. Okay, let's plug in 2 pi, our radius is 20, and our h is 200. Okay, so now we've got 2 times 20 times 200. 2 times 20 is 40. 40 times 200 is 8,000. I think of it this way. 2 times 2 times 2 is 8, right? And then we've got 40 times 200, and so we get 3 zeros. 1, 2, 3. Okay, so there's our perimeter of base times height. So that's our lateral surface area. Okay, and now we just add that to the area of the bases. So our total, oh, I forgot the pi. Hope someone saw that. It's 8,000 pi centimeters squared. So our total surface area is 800 pi plus 8,000 pi. So we're going to go with 8,800 pi centimeters squared. Okay. All right. The base of the right solid, 10 meters high, is shown. So they like us to know that this is 10 meters high. So we draw that in. Find the surface area of the right solid. Dimensions are in meters. Remember that the lateral surface area of a right solid is equal to the perimeter of the base times the height. But we remember that because we now can sing it, rap style. Okay, let's sing it again. The lateral surface area. Should we do the lateral surface area? No, let's do that last. Okay. We'll do the area of the top and bottom first, okay? So I see we have a triangle and a half a circle. So let's find the area of the triangle first. It is 1/2 base times height. I like to write that in case it just helps a lot, gang. All right, now here's tricky. What is our base? I see 8. What is our height? It is not 10. Our height is where the right angle meets the base. The base and height meet at a right angle. So the height is actually from here to here. So how do we figure out that? We'll know that this is a radius, correct? So it's actually, this is also 3 because this is a radius and this is a radius. So that's also 3. So all the way across is 6. Okay, so the area of our triangle is 6 times 8 divided by 2. 48 divided by 2 is 24. And we're in meters, so we've got meters squared is the triangle. Okay, then we have to get the, here, let's do it like this way, semicircle, or I could draw it this way. Area of the semicircle is half of pi r squared over 2. Okay, so pi times the radius squared over 2. All right, and so that simplifies to 9 pi. We've seen this before, over 2. Okay, so our area, again, let's stay organized. What did we just do? The triangle and this together make, let's just say, the area of the top and bottom, right? So let's go ahead. The area of top, area, not T of top, the area of the top equals this plus this. And we can't add this, those two together because this has a pi in it. So we're going to say 24 plus 9 pi over 2 meters squared. Okay, but we want to double that because area of the bottom is also 24 plus 9 pi over 2 meters squared. So if we add those together, the top and bottom, then we get 48. 9 pi over 2 plus 9 pi over 2 is 18 pi over 2, which is 9 pi. You see how I got that? I did that in another example. Just want you to know I said it, so maybe I want you to see it. Okay, that equals 18 pi over 2, which reduces to 9 pi, in case you're wondering where this came from. Okay, so here I'm going to just kind of cross that out so you don't get confused. Okay, so the area of the top plus the bottom equals 48 plus 9 pi meters squared. So we've only got top and bottom. We've not done lateral surface area, okay? Remember, lateral surface area equals perimeter of the base times height. Okay. Perimeter of our base, though, is from here to here, half a circle to here. So that's a little irritating, right? It's 10 plus 8 plus whatever half the circle is. So let's go ahead and do perimeter of the base, okay? The perimeter of the base is 10 plus 8 plus half of a circle. So it's 2 pi r cut in half, right? So we get 18 plus 2 pi times 3 over 2. And let's simplify that. 18, I'm still going to leave him out, 18 plus, that's going to be 6 over 2. So we get plus 3 pi is what that simplifies to. So there's the perimeter of the base, okay? Now let's do lateral surface area. We'll do perimeter of the base times the height. So the perimeter of the base was 18 plus 3 pi, and the height is 10. Okay, so that means we multiply everybody in here times 10. It's 10 times 18 and 10 times 3. So we get 180 plus 30 pi. Yikes. Okay, then we add the lateral surface area to the top and bottom. So let's add that to 48 plus 9 pi. Let's do it that way, okay? So we get 39 pi, and we get 100, nope, I made a mistake there. 228 plus 39 pi. And I always go back, what units are we? Meters squared.
Lateral surface area of eta of eta of eta. The lateral surface area of eta of eta of eta. The lateral surface area of eta of eta of eta. The lateral surface area of eta of eta of eta. The lateral surface area of a solid is equal to the perimeter of the base times the height times the height times the height times the height.